Hey folks, welcome to today's lesson. We're looking at some Venn diagrams and some two-way tables. So a quick brief recap from year 7. A Venn diagram usually looks like two circles interlapping like that, but of course it can be more, can be 3 or 4, and it compares usually 2 or more sets of data. So for example, we could ask a question such as, do a group of boys like football or do they like rugby? Okay, so what's going to happen in that situation? You're going to get some boys who say, hey, yeah, look, I like both football and rugby. You might get some boys who just say, you know what, I love footy, love football, but I don't like rugby. Vice versa, some boys will say, hey, love, mad about rugby, but I don't like football. And of course, you're always going to have a couple of people out the outside who go, you know what, I don't like either of those. Okay? And so, of course, when we get these sorts of questions, you'll get given numbers. For example, you'll say 2 people like both. You might say 10 people like football but not rugby. You might say 15 people like rugby but not football. And then you might have that, another 3 people on the outside who go, you know what, I don't like either. And we can answer a whole host of questions off this. We could say, how many people like football? Well, there are 12 people who like football. How many people like rugby? Well, there are 17 people who like rugby. 3 people who don't. We can say, what's the probability if I choose one person at random, they don't like either football and rugby? We'd say, well, the probability equals 3 people who don't like either. There are 15, and there are another 15, that's 30. There are 30 people altogether. We have 1/10 probability. So, look, there's a whole host of things that we can answer. Okay? As I said, we could interlink and have more than 2. We could have 3, like that, for example. And we could add one more variable in. We could say football, we could say rugby, and then we could say volleyball. You're going to have some of those people who might like all 3 sports. You might have some people who just like football and volleyball. You might have some people who just like rugby and football, etc. And of course, we'll have some people who don't like either. So lots of things we can ask for the Venn diagrams. In terms of your two-way tables, we'll go through those in a bit more detail later on, but generally speaking, a two-way table is comparing 2 things. Okay, and they can look a little bit differently sometimes, but this would be a general thing. So, for example, they might say they like rugby, all right, like rugby, and they say don't like rugby. They could then say, I like football, and then they could say, I'll say no football. Okay? And then often we have on top of that, we have some totals, because of course you're going to have people who like football, you're going to have people who don't like football, etc. You can have numbers there, and then the grand total there at the corner of people who are all together. So, for example, we could say that we have 5 people who like footy and like rugby. We could have some people, 4 people who like football but don't like rugby. You could say people who don't like either rugby or football. That could be 4, and don't like rugby. So like rugby and no football, or don't like either. We'll say 1 person there. And then, of course, from that, you can have some totals. For example, 9 people like rugby, 5 people don't like it, 9 people like football, 5 people don't like it, and of course, in that case, there's going to be 14 people altogether. Then you can answer lots of questions off it. You can answer probability questions. You can answer just normal percentage questions. There's a whole host of things. But look, we want to get cracking. Now, that's a real quick introduction to a Venn diagram and a two-way table. You might want to stick around and have a look at examples. So example 1, we're going to look at this, which is a nice straight Venn diagram. They've given us a whole host of information from the Venn diagram. We want to read off it. First of all, how many people are represented in this Venn diagram? We have 15 people who like the beach but don't like the snow. We have 12 people who like both. We have 10 people who like the snow but not the beach. And of course, we have those 3 people who just don't like either. 15 plus 12 plus 3 is 30, plus 10 is 40. Correct answer. Part B. Now, feel free, gents, to pause this and have a crack at it if you wish, and then check your answers afterwards. How many people enjoy the holidays only at the beach? Well, we have 15 people who just like the beach. How many people do people like the beach in total? we have 15 people and 12 people. That means we have 27 people in total. Third one there, both at the beach and at the snow. Well, that's the 12 in the middle there. And then number 4, neither at the beach nor at the snow. Well, those 3 people at the back end there. C part 1, how many people do not enjoy holidays at the beach? Well, you can see here in red, we've got 10 people who don't like the beach here. We've got 3 people who don't like the beach here, which means we have a total of 13 people. And part 2, very similar, but they don't like the snow. So in purple, we have 15 people there. We have 3 people there, which means we have 18 people in total. A pretty straightforward Venn diagram. Are you still with me? The next one, we actually have to construct a Venn diagram. This is usually the more challenging question. So I'm going to start off, guys, by putting a nice double circle there. Now, I probably should have checked originally to see how many things we're comparing, because you might need to have more than 2. We have 17 people, 13 rented their house, 6 rented a car, and 3 did not rent either a car or the house. So we only have 2 variables here. We have rented a house, we have rented a car. So thankfully, we didn't need that other circle. Now's the hard part, guys. We have to put the data into this diagram. There are 2 types of questions. The first question will give you the amount of people that have both a house and a car. If possible, start from the center and build out. But this question kind of works reverse, because it gives us the amount of people that did not rent a car or a house. So neither. So that gives us these 3 people who are on the outside. Now, that causes a little bit of a problem if you think about it, right? We have 13 people who rented a house. We have 6 people who rented a car, which means in total we have 19 people. Can you see the problem? There are only 17 people to start with, and not just that. If we take away the 3 people who actually didn't rent a house or a car, we actually only have 14 people that should theoretically be sitting inside these 2 circles. So we have to consider the overlap, right? If I know there are 19 people in total who like the house and the car, but there should only be 14 in there, this means that I've counted 5 people extra, which means the overlap is 5 people. All right? That's a little bit hard to kind of gauge. Now, if we think about it, we know that there are 13 people who rented a house. If I've got 5 already counted, well, 5 plus something equals 13. Okay, so 5 plus 8 is 13. If I look at how many people rented a car, we have 6 people rented a car, so 5 plus 1 makes 6. Now let's see if these numbers add up. We have 8 plus 5 is 13, plus 1 is 14, plus 3 is 17, and that gives me the right amount of people. This is the hardest kind of question, in my view, with Venn diagrams. If you work from the center out, that's usually easier than working out and in, but of course, it's up to what the question gives us. Hopefully you kind of understood that. If not, just rewind that a little bit and kind of see if you can make heads or tails, because you're looking for the overlap, because this amount here is going to be counted twice. It's going to be counted in the house and it's going to be counted in the car, and we have to take into account that that's happened. Part A is done, all right? Part B says how many people rented both the car and the house. Well, that's 5 people. And part C says find the probability that one of the people in the group rented only a car. Well, that's 1 person out of my group of 17, so that's my probability. Okay, gents, I hope you're still with me. That's a pretty tough question. The last question, we work towards constructing a 2-way table. Okay, now a 2-way table, as I've already mentioned, okay, is going to be comparing most likely 2 sets of things. Okay, so I'm going to draw up a nice little 2-way table like this. Now, in my 2-way table, it even says to me, it sort of says in here that 24 cars are tested for fuel economy, 18 run on petrol, and 8 run on gas, and 3 run on both petrol and gas. So we've got runs on gas, we'll say doesn't run on gas, so no gas, runs on petrol, and doesn't run on petrol. Doesn't matter which one you put there, okay, as long as they're on one of the 2 sides. So let's answer some questions here. Now, it tells me that there are a total of 24. So we can even add in, and this is often a good idea to add in the total columns for each gas, no gas, petrol, no petrol, and then you have this complete granddaddy total. Okay, and for us, that amount is 24. It says 18 of the cars run on petrol in total. So this column here is my runs on petrol. And if this is my total, then we've got 18 sitting inside here. The next one is asking us about, we have 8 cars run on gas. So this is my gas column. So again, if this is my total, we have 8 people here. And then we have the next piece of information, which really is the clinch for us. It says we have 3 cars can run on both petrol and gas. So I look at the gas column, I look at the petrol column, and this guy in the middle, that he goes with both. So we can put 3 in from there. Now from that information, we can realistically put everything else in there. 8 minus 3 makes 5, or otherwise 3 plus 5 makes a total of 8. Okay, 3 plus 15 makes 18. We've got 8 plus 16 makes 24. Now we can say 15 plus 1 makes 16, and 5 plus 1 makes 6, and of course 18 plus 6 makes 24. So there's lots of ways that you can work that table out, but that's for me, that's the way I did it. And now we answer the question. So part A, all right, we've done that question. We've illustrated it. Part B says, how many of the cars do not run on gas? So do not run on gas. So we've got no gas here. This is my total. We have 16 cars that do not run on gas. So for my answer here, we have 16. Part 2 says, run on neither gas or petrol. Well, we've got no gas, we have no petrol, and that's this little guy here. So that answer is 1. C part 1, it says find the probability that a randomly selected car runs on gas. Well, gas, we have a total of 8 people. So 8 cars, or whatever you want to have, 8 out of 24, which is simplified as 1 on 3. Part 2 says runs on only gas. So we want runs on gas, but does not run on petrol, and that is 5 cars. So we have 5 out of 24. And the last question here, of course, says runs on gas or petrol. Okay, it can be any of it. And in this case, we only have 1 car that doesn't run on gas or petrol, which leads me to believe we have 23 cars out of 24, and that runs on gas or petrol. Okay, gents, we have gone through Venn diagrams extensively and two-way tables. There's been a lot of information to go through, so please feel free to rewind it, have a crack, see if it makes sense. If it doesn't, drop me an email. Otherwise, I hope it was useful, and I'll see you shortly.